Okay, the first 6 ICANs for this unit are here. We've already talked about defining scalar and vector quantities. That was assignment number 1. This one is kind of going to develop number 2 as we work our way through all the ICANs. Number 3, we talked about yesterday and was part of your assignment number 2. Today, this video is going to review number 3 and go over how to do 4, 5, and 6, and I'm going to mention those ICANs as we work our way through. We talked briefly yesterday about if something is moving or not. We also did assignment number 1 about scalars, which are quantities that have magnitude only, and vectors, which have magnitude and direction. Those are questions on your paper. We talked about the idea that a change in position relative to a reference point is motion, and you watched videos. We have a train and a person. So relative to each other, from this point in time to this point in time, the location of the person in the train, the location of the person to the train, or the train to the person has changed. The train to the person has changed. That's a change in position relative to a reference point. You have to have a reference point from which to determine if motion has occurred. In this one down here, we have the light far away, and now the light is closer. Relative to the light, the train has moved. It was in motion. A reference point is a point used to determine the position of an object. You were supposed to define that from your reading, and a frame of reference is a coordinate system based on that reference point. Based on this reference point, a frame of reference is a coordinate system in which the position of an object can be measured. This, from your book, example, the post office, we put at 0, 0. So here is our origin of our coordinate system here, 0, 0. There's the post office. And relative to that now, we can say where everything is. 1, 2, 3 meters north is whatever that is, a bank. We could say 1, 2 meters south and 1, 2 meters east, there's a bus. So relative to our reference point, relative to the post office, we can say where all the other things are located in our frame of reference, in our coordinate system that can be used to measure position of objects. New stuff for today. Distance is a measure of how far an object moves over its entire path, and displacement is how far an object is from where it started. So to look at that, we have this guy who runs across this soccer field, football field, whatever, 50 meters, right? Right here, it's 50 meters to this end line. And then she runs back here. They go back 28 meters in the opposite direction, 28 meters, 50 meters this way, 28 meters that way. So 58 meters to the right, and 50 meters to the right, 28 meters to the left. Their total distance traveled, 78. So we're going to show that with us, lowercase d, 78 meters is their total distance. Their change in position, their displacement, is 50 left, 50 right, 28 left. So their change in position from the starting point is 22 meters. How far are they from where they started? Here's where they ended up. Here's where they started. This is 22 meters according to the way I calculated it. So displacement, how far are you from where you started? Distance, total amount traveled. Let's practice doing that. We can talk about displacement in the same direction can be added. So if we go 5 meters east, stop and tie our shoes, 5 more meters east, our distance traveled is 10 meters, and our displacement is 10 meters. In example number 2, over here, our distance traveled, we go 5 meters east, and then we turn around and go back 5 meters west. Our total distance traveled is 10 meters. The total amount we walked altogether is 10 meters. Our change in position, though, is 0. We go to here, and then we turn around and go back. How far are we from where we started? Our displacement is 0. And if they are not in the same direction or opposite directions, then we can't calculate it. I know we all know Pythagorean theorem, and in years past we've solved for some of these, but we're not doing it this year. These need to be in the same or opposite directions in order to calculate displacement. Let's do some more practice. Alt Z. So some more practice. Here's the example that I showed you earlier, so we don't need that one. Let's say an object moves. This is 1, 2, 3, 4, 5, 6, 7. This is meters as our unit. So if an object moves 4 meters to the right and it moves back 2 meters to the left, what's the total distance traveled? 6. What's its change in position? Its displacement. It ends up here, 1, 2 from where it started, 2, or 4 minus 2. So again, they have to be in the same or opposite directions. What if I had a movement that was 3 meters, stopped, then went 4 more meters in the same direction? 4 meters right plus 3 meters right in the same direction. They add 7 meters total. D and delta X both equal 7 meters. 1, 2, 3, 4, 5, 6. Well, let's do something on the Y because it works both ways. We can go up and down. 1, 2, 3, 4, 5. If I move from here to there and then turn around and walk back here, I go 3 north, 2 south. So opposite direction, subtract, and I ended up 1 meter from where I started. Total distance, 5 meters. Change in position, displacement, 1 meter. What if I go up to, let's go ahead and label some more of these. Each one of these is 1 meter. So if I go up to 2 north, and then I go south 4 south. My total distance traveled is 6. My change in position, my displacement from where I started is -2. That means I went down from where I started. So negative means you went down or left. Negative means you went down or left. If I started here and I went this way 2 and I went, so that was 2 east. And if I go back, come on, man. Did you see me click on red? If I go back 4 west, I am left of where I started, so that needs to be a negative number. I'm 2 meters from where I started, but I'm left of where I started, so -2. So left or down would be negative. If you were left or down from where you started, that should be a negative number indicating that you went back past where you started. So try these 3, and then we'll do some more together on another day. But try these 3, most basic type. None of these are negative, and we'll talk about the negative positive stuff again on another day.